Hello, and welcome back to Entity Framework Core 6 Best Practices. I'm Michael L. Perry. It seems that every week we hear a new story about application data being leaked or compromised. Security is our most important responsibility as application developers. Let's design security into our applications and processes right from the beginning so that we can keep our customers out of the news. A famous parody of application security concerns appears in the XKCD comic Exploits of a Mom. In this story, a mother gives her son a name that would trigger a SQL injection attack when entered into an unprotected school database. The attack works when inputs are concatenated into SQL statements for execution. Thankfully, Entity Framework prevents these kinds of SQL injection attacks when used properly, but it is still up to us to take extra precautions to protect our applications against leaks and vandalism. In this particular exploit, the goal is vandalism. The attack succeeded in dropping a table. The mom admonishes the school official that they should sanitize their inputs, and clearly it's not the user's responsibility to do that, but ours as application developers. Even then, are unsanitized inputs the only problem with this exploit? No, there's something even bigger at play here. Why would an application ever need to drop a table? Why would it have that permission? If the application used credentials that did not have the drop table privilege, then this exploit would have been stopped in its tracks, even if inputs weren't sanitized. We need to apply the principle of least privilege. The principle of least privilege is the position that an actor should have only the privileges that it needs to perform its function. Rather than starting with full capabilities and shutting things down, this position starts with a fully locked down system and carefully opens things up. Take a look at an application from this perspective. While it's running, the application will need to execute select, insert, update, and delete statements. Collectively, these statements are known as Data Manipulation Language, or DML. In Microsoft SQL Server, the privilege to execute DML is assigned to members of the DB Data Reader and DB Data Writer roles. An application needs these privileges to do its job. An application does not need to execute create, drop, alter, or truncate statements. These are collectively known as Data Definition Language, or DDL. SQL Server assigns DDL privileges to the DB DDL admin role. If an application operates in this role, it is not following the principle of least privilege. This is what allowed Little Bobby's Table's mom to vandalize the school's database. An application certainly should not need to execute grant, deny, or revoke statements. These are known as Data Control Language, or DCL. These commands can cause a great deal of damage in the wrong hands. SQL Server assigns these privileges with the DB Security Admin role. There is no reason that an application should operate in this role. And yet, the most common security position demonstrated is a loose one. In fact, we just did that in the last module. We set the application's connection string such that it used a trusted connection. In other words, the application assumed the developer's credentials in order to access the database. The application therefore connected to the database in the DB owner role, which is the most permissive of them all. If we are to follow the principle of least privilege, then we need to assign each actor only the privileges that it needs to do its job. And in Entity Framework, there are two kinds of actors. There's the application, and there's the migrations. Entity Framework applications only need to run Data Manipulation Language. They should therefore be restricted to the DB Data Reader and DB Data Writer roles. Entity Framework migrations, however, need to run not only Data Manipulation Language, but also Data Definition Language. Migrations, not applications, need to create, alter, and drop tables. Furthermore, they need to assign privileges to the application, for example, to execute specific stored procedures. Migrations therefore need to run Data Control Language as well. And so with all the privileges necessary for migrations to do their job, they should run in the DB Data Reader, DB Data Writer, DB DDL Admin, and DB Security Admin roles. On the initial run, migrations may also need to create the database itself. This automatically adds them to the DB owner role of that database, which subsumes all four. Strictly speaking, the principle of least privilege would require us to remove the migrations user from the DB owner role after the initial migration. But practically, there's very little difference between these two positions. The important thing to remember is that applications need far fewer privileges in order to perform their function than do migrations. Carlos wants to practice the principle of least privilege. He changes his connection string in app-settings.json so that it is not using his administrator login. Then he focuses on migrations. Migrations will need more privileges than the application and therefore will require a different connection string. Carlos will configure this connection string in a design-time dbContext factory. By default, migrations will use the registered dbContext options to connect to the database. Service registration happens in the application startup project, which in this case is globoticket.api. That means that migrations will use the same connection string as the running application. Carlos wants to limit the application privileges, so he must run migrations using a different connection. If he were to change app-settings.json, he would not be able to run migrations anymore. He could specify the -- connection flag on the command line. The problem is, though, that he has to remember to specify this flag every time. To make his and his team's lives better, he wants this to be automatic. And so he creates a design-time dbContext factory. A design-time factory creates a dbContext when running migrations. It's a class declared in the application startup project that, if it exists, migrations will use instead of the configured options to create the dbContext. To initialize that dbContext, he creates a dbContext options builder and accesses the options property. He initializes SQL Server and specifies the connection string. So, where should he get that connection string? Well, it shouldn't come from application configuration because that's used for the application runtime. Instead, he reads it explicitly from an environment variable. And if that environment variable is not set, he provides a helpful error message. And to make sure that he can add migrations to the correct assembly, he sets the migrations assembly inside of the SQL options. Now Carlos can set this environment variable, and then when he runs migrations, it will use this connection string. The connection string is kept outside of app-settings.json, so he is now free to provide the application with a connection string that has limited privileges. Now, Carlos isn't going to leave this password in app-settings.json, but before we get to that, let's talk about application privileges. Now Carlos wants to configure a connection with limited application privileges. He will first create a database role. This will give him control over granular privileges independent of the authentication mechanism. Then, he will create a new database login for his application and assign it to that role. To deploy the application database role, he creates a custom migration. When the migration runs, it'll create the role globoticket_app. He uses the authorization clause in order to assign the owner of this new role to dbSecurityAdmin. This will allow any security admin to add members to the role. The role globoticket_app will control access for the application user. Carlos wants to grant the application permission to execute data manipulation language statements. These are the typical select, insert, update, and delete statements that the application will need. These permissions are granted to members of dbDataReader and dbDataWriter, and so he will add globoticket_app as a member of both. When he needs to grant additional privileges to the application role, such as when he creates a new stored procedure for the application to execute, he'll create a new migration. In the down method, he reverses these actions. Now when Carlos runs the migrations, the globoticket_app role is created. The role itself is a member of the dbDataReader and dbDataWriter roles, but it has no members of its own. Let's go ahead and fix that. Carlos creates a database login called app specifically for the application. He randomly generates a password and stores it in his secrets manager. He's using KeePass. Next, he needs to add that login to the globoticket database. so he creates a user inside of the database for the login. The user is also called app. Then he assigns that user to the GloboTicket app role. Now when Carlos logs in as app, he can access the GloboTicket database. He is able to issue DML statements, like select and insert, that the application is going to need to perform. But he is not able to execute DDL statements, like drop. Nor is he able to elevate his own privileges with DCL statements, like grant. The login has the minimum required privileges for the application. If the principle of least privilege is the most important security position, then shift left is a very close second. The idea is to consider application security in the early stages of the delivery process. Delivering value through software is a process, and you can envision this process as a pipeline. It begins on the left with planning. The process continues toward the right, bringing in activities that occur on the developer workstation, shared development and test environments, and then finally, production environments. Security is far too often considered late in the process, further to the right in the pipeline. The idea behind shifting left is to distribute security checkpoints throughout the process. Take each decision and see how far left it can be moved. Let's see how this applies to EF Core. Securing a database connection is certainly very important during the deployment phase. But can we shift that idea left? What could we learn by securing database connections during test? Perhaps we could enable early penetration testing efforts. Or how about even earlier? What could we gain by securing database connections during the coding phase? If developers operate under minimal privileges while coding, then they will immediately see when privileges need to be escalated. Code reviewers could explicitly look for privilege escalations and ensure that the appropriate conversations have taken place. How do developers practice security during the coding phase? Where should they keep their secrets? In appsettings.development.json? No, absolutely not. That file is checked into source control. We need to store secrets in a file outside of the source tree. .NET has a ready-made answer for this: user secrets. User secrets are app settings that live only on the developer workstation. Now, user secrets are only appropriate for developer workstations. They don't work for shared environments. But when you're shifting left, the developer workstation is a good place to start. Carlos decides that it's best for his entire development team to practice security early in the process, right on their developer workstations. And so, rather than using local administrator privileges or establishing a common password that they all use, they should each set up their own unique credentials. He shows them how to do that and how to store those credentials in user secrets.